Hey guys, welcome back to Math Principles. Today we're going to take another look at factoring quadratics. But before we get into factoring quadratics, I want to take a look at something called foiling. If I want to multiply together these two quantities, x plus 2 in a set of parentheses times x plus 3 in a set of parentheses, there's a special way that we need to multiply those together. And there's a trick that we've used, and we call it foiling. Now I want to take a look at foiling because it kind of explains how factoring works. I think you've done foiling before, but just to cover it again, FOIL stands for firsts, outers, inners, lasts. Okay, and what this represents are the four terms of, or pairs of terms that we multiply together when we're multiplying two binomials. And that's what this is called right here, a binomial. Bi meaning two and nomial meaning terms. So we're going to multiply these together. I need to multiply first the two firsts together. Now those are the two first terms in each quantity. So x times x gives me x squared. Okay? Then my outers, I would do x times 3, and that's going to give me 3x. Myself a little space here, a little bit better. So I've got x squared plus 3x. And then I want to multiply the inners. Okay, so those are the two on the inside. So that's 2 times x, which is 2x. And then finally, we want to do the last. Okay, and that's the last term in each quantity. 2 times 3 gives me 6. So this is foiling. Now, the one last thing that we would do here is we would combine these like terms, 3x and 2x, and get x squared plus 5x plus 6. And that is the product of those two binomials. Okay, we multiply them together using that foiling trick. Now, really, guys, foiling is just distributing. I distribute the x over the quantity. I distribute the 2 over the quantity. And then if we have like terms, we combine them. That's how foiling works. That's how multiplying these binomials works. So let's take a look at a couple more examples. Okay, x plus 4 times x minus 3. X times x gives me x squared. X times minus 3 gives me minus 3x. 4 times x gives me plus 4x. And 4 times minus 3 gives me minus 12. Now notice when I multiply those, the sign in front of that term stays with that term. So when I multiply by this 3, I have to keep in mind that I'm multiplying by a negative 3. So that negative goes along with that 3. Now we still combine those like terms, and we'll have x squared plus 1x, or simply plus x, minus 12. Okay, let's take a look at just two more. X plus 5, x minus 5. Well, if I multiply the first, x times x gives me x squared. If I multiply the ones on the outside, x times minus 5 gives me minus 5x. Plus 5 times x gives me plus 5x. And 5 times negative 5 gives me minus 25. And when we combine our like terms here, minus 5x plus 5x, those cancel out completely. And I just have x squared minus 25. And the last one that we have here, we have 2x minus 1 times x minus 3. Well, 2x times x. 2x times x gives me 2x squared. 2x times minus 3 gives me minus 6x. Negative 1 times x gives me minus 1x. And then minus 1 times minus 3 gives me plus 3. Negative times a negative is a positive. And then when we combine our like terms, we have 2x squared minus 7x plus 3. Okay, so that's foiling. When we multiply those terms together, multiply those two binomials together, we end up with these expressions with the x squared. Now those are called quadratics. And when we try to solve a quadratic equation, there are a few tricks that we can use. One of them is factoring. And factoring, what it does is take this as our original, okay, this expression right here with the x squared minus 25, and we rewrite it in terms of those factors. And that's going to be a process that we can use that helps us to solve those equations. So we're going to take a look at that today. So, factoring. Factoring is writing an expression as the product of its factors. So for example, if I factor 10, I can write that as 5 times 2. If I factor x squared, I can write that as x times x. If I have x squared minus 5x plus 6, I can rewrite that as x minus 3, x minus 2. And just to show you, if I FOIL this out, x times x gives me x squared. X times minus 2 gives me minus 2x. Minus 3x, or excuse me, minus 3 times x gives me minus 3x. And minus 3 times minus 2 gives me plus 6. And when we combine our like terms, we get x squared minus 5x plus 6. So we're rewriting this quadratic in terms of its factors. Now, I'm going to use some terms during this lesson, and I want to make sure that we have those words in mind. So first off, a quadratic is an expression where the highest exponent is x squared. That's what makes it a quadratic. So this a in front of x squared is known as the quadratic coefficient. Okay, it's the number that multiplies x squared. B is called the linear coefficient. Okay, x is just the linear term. It's just regular old x, not x squared. So b being what multiplies it, that's the linear coefficient. And then we have c, which is the constant term. There's no x on it at all. It's constant. Now, a, b, and c, we're going to use integers. For each of those. Okay, and remember that z with the double slash, that means integers. Those are your counting numbers. They're opposites in 0. But the catch is a cannot be 0. If a is 0, then we don't have an x squared. B and c can be 0. And we're going to take a look at what happens in some special cases when b or c equals 0. But when we try to factor these expressions, the very first thing that we try to do is bring out a GCF, so a greatest common factor. So for instance, if I have 2x minus 6, I want a number that divides both 2x and 6, and I should say a value that divides both of those. So something that divides both 2x and 6 is 2. So I write down a 2, I open up a set of parentheses, and I divide each term by 2. 2x divided by 2 gives me x. Bring over that minus sign. 6 divided by 2 gives me 3. Okay, and that is bringing out a GCF. Then, when I go to factor the quadratic, or factor what's left, I'm going to consider B, C, and the chart below. Okay, now we talked about this last time, so I'm just going to skim through it pretty quickly here. These are my two factors. Okay, this is a factor, and this is a factor. When I talk about the outers, I'm talking about what happens when I multiply these two together. And when I talk about the inners, I'm talking about what happens when I multiply these two together. Okay, so if my C term is positive, so that constant term, if it's positive, I know that both of my factors are going to have the same sign as Bx. So whether that Bx is positive or negative, okay, whether this Bx is positive or negative, both of my factors are going to have the same sign. And I need to be able to add those outers and inners together to get that Bx. If my C term is negative, I know one factor is plus, one factor is minus, and the larger outer or inner gets the same sign as Bx. And also, I need to be able to subtract the outers and the inners to get Bx. Okay? Now, this chart will work to factor any quadratic that can be factored. Bring out a GCF first, and then focus on this chart. So let's take a look at some examples. I have x squared plus 7x plus 12. Okay? Now, the first thing that I would try to do is bring out a GCF, something that divides every term. But there's nothing that divides all three of those terms. So I'll go to my factors. So I'll have two sets of parentheses. And I know that my first need to multiply to give me x squared. Well, the only option there is x and x. My last need to multiply to give me 12. So I'll list my options. I have 12 and 1, 6 and 2, and 4 and 3. I need factors. I need numbers that are going to multiply together to give me that 12. So I have to use one of these pairs. Now, because my C term is positive, I know that both of my factors get the same sign as bx. So I know they'll both be plus. Then I know that when I check my outers and my inners, those are going to have to add to give me that bx. So the bad news here is it's just guess and check. Okay, we just have to try pairs until we find one that works. Now, I've been doing this for a while, so I know that 4 and 3 are going to be the numbers that we want. But we should, no matter how certain we are, we should always check our outers and our inners. So on the outside, x times 3 gives me 3x. On the inside, 4 times x gives me 4x. And if I add 4x plus 3x, that gives me the 7x that I need. So this is the factoring that we want. Okay, let's take a look at number 2. Now, on number 2, I see a 2 in front of that x squared. So I'm thinking maybe I can bring out a GCF. So I look for a number that divides all 3 terms. And they're all divisible by 2. So I write down a 2, I open up one set of parentheses, and I divide each term by 2. 2x squared divided by 2 is just x squared. 12x divided by 2 is 6x. And 10 divided by 2 is 5. Now, I have 2 times the quantity x squared plus 6x plus 5. Now I'm going to focus on factoring just this bit. Okay? I leave the 2 out front, I get my 2 sets of parentheses, and I factor this highlighted piece. So in order to get x squared, I know that I have to use x and x. My C term is positive, so I know both of these factors are going to be the same sign as bx, which this time is plus. I know that my numbers need to multiply to give me 5, so I really only have one option here. I've got 1 and 5. Okay, now, no matter how certain we are, we should still check the outers and the inners to make sure that it works. So if I sub in 1 and 5, and I try this, on the outside, x times 5 gives me 5x. On the inside, 1 times x gives me 1x. Because my C term is positive, I need to be able to add those two to get 6x. Well, 1x plus 5x does give us 6x. So this is the factoring that we want. Now that 2 is part of our answer, so we're going to leave it there. GCF stands for greatest common factor. So 2 is a factor, it's part of our factoring, we're going to keep that in our answer. Okay, let's take a look at number 3. On number 3, I have 11x squared minus 77x plus 66. Now these are some pretty big numbers, so I'm definitely hoping that there's a GCF I can bring out here. And when I look at these, I notice that they're all divisible by 11. So I write down 11, I open up one set of parentheses, and I divide each term by 11. 11x squared divided by 11 is just x squared. 77x divided by 11 is minus 7x. Plus 66 divided by 11 is plus 6. So now, I'm going to focus on factoring just this piece. Okay, I'll leave the 11 out front, get 2 sets of parentheses, and factor as usual. I know that in order to get x squared, these have to start with x and x. Then I need numbers that multiply to give me 6. So my options are 6 and 1 and 3 and 2. So I have to use one of those pairs. Now, I know because my C term is positive, both of these factors are going to get the same sign as bx. So they're both going to be minus. Okay? Now, the only thing we can do here is guess and check. So we'll pick one of those to try. We'll sub them in. Let's start with 6 and 1 and see what we get. On the outside, x times minus 1 is minus 1x. On the inside, minus 6 times x is minus 6x. Now, because my C term is positive, I need to be able to add these two to get that minus 7x. Well, minus 6x plus minus 1x does give me that minus 7x. So this is the factoring that I want. And remember that 11 is a factor, so I keep that in my factoring. Okay, next up, number 4 here. I have 5x squared minus 50x plus 125. All right, so one more time. I see all these big numbers. I'm hoping for a GCF. Well, all three of these are divisible by 5. So I write down a 5, open up one set of parentheses, and divide each term by 5. 5x squared divided by 5 is just x squared. Minus 50x divided by 5 is minus 10x. And plus 125 divided by 5 is plus 25. All right, now this is looking a whole lot better. Now I leave that 5 out front, but I'm going to factor what's inside those parentheses. So I write down the 5, open up two sets of parentheses, and get to it. So I know in order to get x squared, they have to start with x and x. My c term is positive, so I know both of these factors have the same sign as bx, which is minus. Then I need numbers that multiply to give me 25. Okay, well, I have 25 and 1, and I have 5 and 5. And the bad news is I have to just try them until I find one that works. Okay, well, if I try 25 and 1, on the outside, I'll get minus 1x, and on the inside, I'll get minus 25x. Because my c term is positive, I know that I need to be able to add these two to get negative 10x. Well, negative 25x and negative 1x do not give me negative 10x. So I'll try the other way. Excuse me, I'll try the other terms. I'll try 5 and 5. And on the outside, x times minus 5 gives me minus 5x. On the inside, minus 5 times x gives me another minus 5x. My c term's still positive, so I still need to add these two to get that minus 10x. Negative 5x plus negative 5x gives me that negative 10x. So this is the factoring that I want, including that 5 out front. Okay, let's take a look at another one here. X squared plus 8x minus 20. Okay, there's no GCF this time. There's nothing that divides all three of those terms. So I'll get right to it. Two sets of parentheses. In order to get x squared, these have to start with x and x. Now this time my c term is negative, which means one of these is going to be plus and the other one's going to be minus. But I don't know which one's which until I put the numbers in, okay, because that depends on the outers and the inners. So now I need numbers that multiply to give me 20. Well, I've got 20 and 1, 10 and 2, and 5 and 4. And the bad news is we just have to try them until we find the one that works. Well, tell you what, I'm going to start in the middle with 10 and 2. Now on the outside, x times 2 gives me 2x. On the inside, 10 times x gives me 10x. Now because my c term is negative, I need to be able to subtract these two and get 8x. Well, if I do 10x minus 2x, that gives me 8x. So these are the numbers that I want. They're in the right places. I need to pick where the signs go. 10x is the larger outer or inner, and the larger outer or inner gets the same sign as bx. So this 10x has to be plus, which means that this 10 has to be plus. So this 2 has to be minus 2x, so this has to be x minus 2. And there we go. This is the factoring that we want. All right, moving right along. Example 6 here. I have 2x squared plus 5x minus 3. So I'm going to start out looking for a GCF, but there's nothing that divides all three terms. So I'll go to my two sets of parentheses. Okay, now in order to get 2x squared, I need to have numbers here, or excuse me, values here, that multiply to give 2x squared. So I can't just use x and x. That only gives me x squared. I need to use 2x and x. Now this is going to change a couple things for us. We have to be a little bit more focused on our outers and our inners here. Okay? So the good news is I only have one option. I only have 1 and 3. Those are the only numbers that I can use that multiply to give me 3. Because my c term is negative, I know one of these is going to be plus and one of them is going to be minus, but I don't know which one's which until I put the numbers in. So let's just try. Okay, well, on the outside, 2x times 3 gives me 6x. On the inside, 1 times x gives me 1x. Because my c term is negative, I need to be able to subtract these two and get that plus 5x. Well, 1x minus 6x gives me negative 5x. But 6x minus 1x gives me 5x. So these are the right numbers. They are in the right places. I just need to get the right sign. Well, the larger outer or inner gets the same sign as bx. 6x is bigger, so it gets the plus, same as bx, and 1x gets the minus. So 2x minus 1 and x plus 3. And there we go. All right, moving right along. Two more to look at right now. 3x squared plus 13x plus 12. So I look for a GCF, something that divides all three terms, but there's nothing that divides all three of those terms. So I'll go to my two sets of parentheses. Now once again, our first need to multiply together to give us 3x squared. So I can't just use x and x. That will only give me x squared. So I have to use 3x and x. Now, I need numbers that multiply together to give me 12. So my options are 12 and 1, 6 and 2, and 4 and 3. So I'm just going to guess and check until I find one that works. Now, I know that I need to be able to add these two together to get that 13x. Okay? So my first thought is, well, I'll try the 12 and the 1. Because 12 plus 1 gives me 13. But check your outers and your inners. Because 3x times 1 is 3x. And 12 times x is 12x. And if I add 12x and 3x, that gives me 15x, which is not what I need here. So it's not going to be 12 and 1. And even if I switch those around, then I'll have 36x and 1x. And that's not going to be what we need either. So we're going to have to try a different pair. Now, my c term is positive, so I forgot to mention, I do know that these are both going to have the same sign as bx. They're both going to be plus. But I still need to figure out which numbers are going to work here. So let's try 6 and 2. On the outside, 3x times 2 is 6x. On the inside, 6 times x is 6x. 6x plus 6x doesn't give me 13x. So we're still not there, but we're getting close. Let's try switching them around. 2 and 6. On the outside, we get 18x. On the inside, we get 2x. Well, if I add 2x and 18x, that gives me 20x. So those aren't the right numbers either. Okay, so we only have one more pair to use. So let's try 4 and 3. On the outside, 3x times 3 is 9x. On the inside, 4 times x is 4x. And my c term is positive, so I need to add 4x and 9x, and that gives me 13x. So this is the factoring we want. So like I said, guys, the bad news is sometimes you're going to have to guess and check. Once you've done a lot of these, though, you'll start to feel a little bit more comfortable, and you'll be able to skip the ones that you know are not going to work, and you can try the ones that are more likely to work. Okay? Just takes time, just takes practice. So let's take a look at one more. I've got 5x squared minus 7x minus 6. Now, once again, there's no GCF. There's nothing I can take out of all three of those terms. Now, to get this 5x squared, I need to start with 5x and x. My c term is negative, so I know that one of these is going to be plus, one of them is going to be minus, but I don't know which one's which until I put the numbers in. So let's talk about what numbers we can use. Well, we can use 6 and 1, and we can use 3 and 2. Okay, well, let's see which ones are going to work. I think 3 and 2 is going to be the pair that we'll use. So let's try 3 and 2. On the outside, 5x times 2 gives me 10x. On the inside, 3 times x gives me 3x. Now my c term is negative, so I need to be able to subtract these two and get that minus 7x. Well, 10x minus 3x gives me positive 7x. 3x minus 10x gives me that negative 7x. So these are the right numbers, and they're in the right place. I just need to figure out which number, or which outer or inner gets which sign, plus or minus. Well, the larger outer or inner gets the same sign as bx. Since 10x is bigger, it's going to get this minus sign, which means the 3x gets the plus. So I've got 5x plus 3 and x minus 2. And that's how we factor. So when we factor, guys, the first thing that we always try to do, if we can, is bring out a GCF. A GCF is a value that multiplies every term in the expression. Once we have that GCF removed, we're going to look at the C term. If the C term is positive, both factors get the same sign as bx. If it's negative, one's plus, one's minus. We won't know which one's which until we put the numbers in because the larger outer or inner gets the same sign as bx. If C is positive, we have to be able to add those outers and inners to get bx. If our C is negative, we need to be able to subtract those outers and inners to get bx. Once again, there is an element of guess and check. When you are choosing which numbers to sub in, okay, it's not always going to be only one option. It's not just going to be 1 and 5 every time. Sometimes you'll have multiple options that you can use, and you just have to try them until you find one that works.